Hello, my name is Hany Windri Astuti from Polytechnic Negeri Semarang. In this occasion, I'm looking forward to talking with you today about our topic that is rain rate influence on performance of Semarang 5G-NR channel model. This research is part of penelitian terapan or applied research funded by Ristek BRIN and led by Professor Mukhlisin with research title Aplikasi Pengembangan Kombinasi Beberapa Sensor untuk Deteksi Dini dan Real-Time Monitoring Daerah Rawan Longsor pada skala laboratorium dan skala nyata di lapangan. Well, my talk is divided into 5. First is the motivation, then I'll share you about the objective, method, results and discussion, and finally, I'll give you the conclusion. Well, let's start with the motivation behind this research. 5G is expected to be able to overcome problems with coverage, interconnectivity, and poor QoS that began the use in 2020 and will be completed in 2030. Well, an important part of 5G-NR is millimeter communications. Become an important part of 5G mobile network in order to provide enhanced mobile broadband services such as VR, AR, or ultra-high definition video. But the problem is that the blockage of electromagnetic signal is one of the challenges in millimeter wave communications, and rain rate is one major cause of obstacle for propagation of millimeter waves from transmitter to the receiver in 5G system, especially due to heavy rain in tropical regions. Hence, we conducted a research on rain rate influence in 5G-NR performance analysis by performing channel modeling and looking at the value of bit error rate and outage performance. Well, the aim of our work was to further broaden current knowledge of rain rate influence to 5G-NR performance in terms of outage and bit error rate performance, especially in tropical region and categorized as tropical rainforest climate, namely Semarang, in Indonesia, with a frequency of 28 GHz. Now, I'd like to move on to the method. We modeled the channel using NYU Sim. That is a channel simulator developed by NYU Wireless or New York University Wireless with following values. With the frequency of 28 GHz and the bandwidth of 100 MHz, and also the rate is equal to 1 or it's done uncoded. For NYU SIM input, with the scenario of urban micro, and also non-line of sight environment, lower and upper bound of 200 meter, the TX power is 30 dBm and the RX location is 1000. Well, for the criteria, we use 3, that is very heavy rain, moderate, and no rain. And this is a complete complete criteria for doing this evaluation of performance of 5G-NR due to rain rate influence. Well, ladies and gentlemen, to evaluate the performance, we took first these 3 criteria. Yes. And this 3 criteria is based on the standard of Indonesian Agency for Meteorological, Climatological and Geophysics, or also known as BMKG. According to BMKG standard, very heavy rain is classified into rain rate more than 20 mm per hour, while in the moderate rain is classified in 5 to 10 mm per hour. Well, BMKG Semarang kindly provided the real field environment data of rain rate, temperature and humidity as well as air pressure in the period of January to December 2018. And these values are as following. Okay, Let's move on to the results and discussion. Well, ladies and gentlemen, it is noted that rainfall particularly required in radio waves at frequency beyond 10 GHz. Well, this figure shows the results of the outage performance validated by frame error rate under R of rate equal to 1. Well, when EBN 0 is in 10 dB, the outage of very heavy rain obtained 1.31 times 10 to the power of minus 2, while the moderate rain obtained slight different from very heavy rain, that is 1.28 times 10 to the power of minus 2, while in no rain obtained the same value as very heavy rain. Subsequent analysis on frame error rate with the value of EBN 0 in 10 dB shows the value of very heavy rain in 5.054 times 10 to the power of minus 1, while in the moderate rain, which is slight difference too, that is 5.056 times 10 to the power of minus 1, while in no rain got a slight difference too, that is 5.042 times 10 to the power of minus 1. Ladies and gentlemen, I'd like to bring your attention to this figure. This figure shows the results of theoretical and CPOFDM bit error rate under R or rate equal to 1. In condition where EBN 0 is 10 dB, the theoretical bit error rate in very heavy rain, moderate and no rain obtain the same value. The value is 2.33 times 10 to the power of minus 2. Meanwhile, at EBN 0 of 10 dB, in CPOFDM with rate equal to 1, the results either for very heavy rain, moderate or no rain obtain also the same value, namely 2.1 times 10 to the power of minus 2. So, it appears that the bit error rate value of uncoded 5G CPOFDM tends to be the same as bit error rate performance theory, but only has slight difference, which is better due to the multipath fading effect on 5G channel modeling. Okay, ladies and gentlemen, we can see that actually with the different rain rate, the curves or the graphs of outage probability and also the bit error rate obtain the different values for each criteria. So, to assess whether there is a significant influence of rain rate to performance of outage and also bit error rate, one-way ANOVA test was performed by inserting all the values of outage, bit error rate, and frame error rate for each rain rate criterion. Well, this simulation is, or this analysis is done partly for each performance. Yeah. So, based on the calculation, we can see that it all obtained p-value in 1. On combining this result with significance of 0.05, thus this p-value is more than 0.05, which means that the value is accepted. Therefore, it comes to the conclusion that actually there is no significant influence of rain rate on the performance. Thus, the effect of rain rate may be ignored. So, ladies and gentlemen, let's go to the end of this presentation. Well, I'd like to conclude that this research has evaluated rain rate influence in 5G-NR at 28 GHz frequency channel modeling performance in Semarang City as a tropical region. The results of outage and bit error rate shows the different curves with respect to the different rain rate value, that higher rain rate generates slightly worse performance. However, although different rain rate generates different performances of 5G-NR in terms of outage and bit error rate, in fact, proven by one-way ANOVA analysis, the inference of rain rate is not significant. Well, ladies and gentlemen, that's all I have time for. Thank you so much for listening.